Hello students. Today's session we will discuss about the I/O performance, reliability measures and benchmarks associated with the uh, storage, secondary storages. So the primary performance measures of a storage uh, device is throughput as well as the response time. So as we all know that throughput can also be called as bandwidth, and the response time can also be called as latency. So if you take an example, that is a traditional producer consumer or producer server model to represent the response time and throughput. So a producer produces the task to be performed. So some task will be produced by the producer and which will be given to a queue, and from the queue the server takes that from the queue and it will perform the task. So the task will be program is being produced by a producer and it is submitted to the queue, and from the queue the server will be accessing that and will be performing the action or performing some operation on the task received from the queue through the producer. So this is actually happening with any operations related to the computer. So some task to be placed into the queue, take that from the queue and do some operation on that particular queue. So we'll see the comparison between the throughput and response time. So response time is the time a task takes from the moment it is placed in the buffer. So buffer indicates the memory until the server finishes the task. Time a task takes from the moment it is placed in the buffer until the server finishes the task. So a task is being placed into the buffer, that is the memory, and from memory it is to be taken to the server and finish the task. So this entire time, that is called as response time. A task is given here. Initially it is placed in buffer, then server will take it, process it, complete it. So this entire time is actually called as response time. Now throughput is the average number of tasks completed by the server within a given time. So the average number of tasks completed, the number of tasks completed within a, so 1 hour is given. So how many tasks are being completed? That is that actually defines the speed of the system. So how many tasks can be completed within a limited time. So when we look into this graph is the throughput versus response time. So percentage of maximum throughput. So you can see that how this graph goes. So if more throughputs is being produced, means more number of tasks to be completed within a given time, we can see that when the number of tasks increases, the response time or latency will also be increases. For example, 40% of throughput will be produced by using some 50% of 50 unit of 50 millisecond of time. But if more tasks to be completed, that means some 80% tasks to be completed, it will take some more time, around 150 milliseconds. So automatically if some 100% on some large amount of throughput is being generated, it will take some around 250 milliseconds. So even if the time increases, slight increase in the time, the throughput will also, because more tasks can also be completed. So this is the normal trend of the graph when we compare the latency, the time, the response time taken, and the number of tasks, that is the throughput of that particular system also. So this is a measures that, so the two major measures that is to be considered when we consider about the secondary storage is the response time, the time taken for completing the task, and the throughput, that decides the number of tasks to be completed within a given limited time. Now an interaction or transaction with a computer is divided into three. So this type of communication can be divided into three. One is the entry time, the time for the user to enter the command, the time taken for giving the request, Now the response time, system response time, is the time between when the user enters the command and the complete response is displayed. Okay, so the time taken for entering the command, then the time taken for getting the command and get the complete response, that is the entire system response time. Then there is a time called as think time, that is a time when the reception of the response until the user begins to enter the next command. So after getting the first response, the user will be thinking for some time for giving the next command. So that is the think time. So the overall transaction time can be defined as the entry time plus system response time plus the think time. That is the transaction time that is considered for evaluation in the case of a computer system. So the productivity is inversely proportional to the transaction time. Productivity. So productivity is actually depending on the transaction time it is taken. So as the transaction time increases, normally there will be some issues related to the productivity also. Now we will discuss about some transaction processing benchmarks. So we know transaction processing or OLTP, that is online transaction processing, they are related to the database system where we are trying to access the data that is stored in the secondary database storage. So most of the time secondary storage access example is taken as the database example where we are trying to access the huge database which is stored in the database system. So normal transaction processing, normal database operations, and online transaction processing where comes the usage of additional time for the network related operations also. So it involves changes to a large body of shared information from many terminals. It also so the benchmark related to the transaction processing involves the changes to the large body of shared information from many terminals. So it depends on the different request that is being submitted by various terminals. Also the benchmark guarantees the proper behavior on a particular failure happens. So how it will be dealing with the failure. So the resolution of failure will take some time, but that will also decide the overall evaluation of that particular system. For example, airline reservation system or bank, all are examples of transaction processing where they are trying to access the data where some reservations are being done or some bank transactions are being done. So for this general database related transaction processing, TPC, that is the Transaction Processing Council, has defined 8 different benchmarks so that we can have a comparison. Based on the benchmark we can decide whether it is a qualified or whether the operation is up to the level, or whether we can whether the performance is a good one or whether it is an average one or whether it is not up to the mark. So as we have discussed in the initial modules about general benchmarks, why we are going for benchmark, it is just for comparison processes in the initial case. Now we are considering about some benchmarks where we are considering different transaction processing and the benchmarks associated with those transaction processing. So we'll see some of the benchmarks. So these are the TPC benchmarks. Here you can see that benchmark A. So these are only some listing and some description regarding that related to what. Some transaction processing consists of several factors. So benchmark A is related with debit card, which is retired, means currently it is not being utilized. This benchmark is currently not available. So a debit card, the data size requirement in GB is 0.1 to 10. and the performance metric is number of transactions per second, and it was initially released in July 1990. Then we were using another benchmark, so that is B benchmark, batch debit credit. The data size is same, performance metric also same. It was released, or the first results were obtained in July 1991. So these two are retired now. Now these benchmarks are not available. Now C is another benchmark that is used with complex query online transaction processing. It is having more memory capacity, like 100 to 3000 GB data, and it is having the performance metric of the transactions per minute. Transaction per minute. Here it was transaction per second. Here it is transaction per minute. And the first results were obtained in 92. Now next benchmark is D, that is decision support, which is not available now. It is retired. Data size varies from 100, 300 to 1000, and the performance measures is based on queries per hour, number of queries per hour, and the results were produced in 95. Now next benchmark is H, that is ad hoc decision support. Uses the same capacity as the previous one. It also focuses on number of queries per hour, and the results were obtained in 1999. Then the next benchmark is R benchmark, based on business reporting decision support, which is currently not available. Its data capacity is 1000 GB. Queries per hour is the performance metric, and it was released, or results were obtained during 1999. And next benchmark is W, that is transactional web benchmark. These are the names of benchmark. It is approximately around 500 GB as the requirement. Number of web interactions per second was the performance metric, and the results were obtained. First results were obtained during July 2000. Then we are having another benchmark, that is application server and web services benchmark. The requirement of data is around 2500 GB, and the performance metric is based on web service interactions per second, and the first results were obtained during June 2005. So these are the various benchmark names which were associated with database transaction processing. For each of these benchmarks, these were the data size requirements, and these are the performance matrices that are being followed in all of these benchmarks, and these are the results when the benchmark produced some successful results. And from this we can see that TPC, it is also called as TPC A, B, C, D, H, R, W, app. These are the names of benchmarks: TPC A, TPC B, TPC C. So here TPC A, TPC B, TPC D, and TPC R, all these are retired now. They are not currently available. Based on other benchmarks, we are doing the performance evaluation of various transaction processing. So TPC-C is actually based on online transaction processing. So some explanation regarding these benchmarks. It is measured based on transactions per minute, and also based on the price of the system. Transactions per minute, and also based on the price of the system. And the characteristics of TPC-C is the price is included along with the transactions per minute. The data set must scale in size as the number of output increases, that is throughput increases. Data set must also be changed, increased according to the throughput. Then all the results are audited, that is the results obtained based on these benchmarks are audited in the case of TPC-C benchmark. Now the throughput is the performance metric, but response times are limited. So the main performance metrics is the throughput, but the response times are actually limited in this particular benchmark, and these benchmarks are maintained by an independent organization. the details are maintained by an independent organization for the case of TPCC. So one example is taken for giving this explanation. So similarly for all other transaction processing also they are following the similar pattern. Similarly for we are using some benchmarks related to the file servers, mail and web related operations. We are using a spec system for the benchmark as for the file servers, mail servers and web servers. Some examples like SFS. It is a spec SFS. It is used for measuring file server throughput, so the access of the file through the server. It is also the access to the secondary of the server, the throughput, the number of tasks to be completed, and also the time taken for completing the task on the network file system. We are using spec SFS benchmark. Similarly, another version of SFS, which is the upgraded version of the same spec. So we can see the average response time versus throughput for two Netapp systems. So the operations, the number of operations per second, and the response time. Just it is an example comparison that is already being described by the author. So you can see that the different operations, that is response time for various systems like FAS 3000 and FAS 6000. These are the two Netapp systems. So here you can see that the development in response time, so more operations per second. You can see that in the case of FAS 6000 the response time is less when we compare that with FAS 3000. It takes a less number of operations per second, but that takes more response time. But in the case of FAS 6000 you can see that more number of operations per second, and the entire response time is restricted within 4 to 5 milliseconds. So this already FAS 600 is 6000 is the enhanced version of FAS 3000. So you can see the development in the response time, more operations in less time. Now some more examples of benchmarks related to these web related operations. Spec mail is an example. It evaluates the performance of mail servers at an internet service provider. So for evaluating the performance of a mail server, we are using the benchmark spec mail. Then an enhanced version of spec mail, that is spec mail 2001. It is based on the protocols SMTP and POP3, which is used for mail applications. It measures both throughput as well as the response time. It also scales the number of users from 10,000 to around 10 lakh. So it is maintaining or evaluating based on this much number of users. Another example for the benchmark is spec web, which evaluates the performance of www servers, that is the World Wide Web servers. It measures the number of simultaneous users per session. So how many? So if a server, a website is being accessed by more number of users simultaneously, how the load can be, how the access speed or how it can be accessible to the number of users can be evaluated based on the benchmark spec web. So we were simply discussing about some of the benchmarks associated with transaction processing, which is usually dealing with the secondary storage, and also we have seen some more examples of benchmarks which is associated with the email related operations, web access related operations, and similar network related operations. So this portion actually covers some of the benchmarks that is used for the IO performance, input and output operation, reading and writing related to the regular secondary database or secondary storage device, and also comes the delay due to the network control when we are dealing with the server and associated disk when we are trying to access the data through the network. So we require some specialized benchmarks for that performance evaluations, and we have seen these two categories of benchmarks. One is related to the transaction processing, the benchmarks defined by the TPC, Transaction Processing Council, and we have seen some benchmarks that are used for web related or mail related benchmark defined by spec. So that is all about the benchmarks related to the IO performance and similar measures. Thank you.